ByteDance, the company behind TikTok, has built a robot that follows voice commands and does real tasks. It can fold clothes, clean tables, and sort objects, all on its own. The system uses a smart AI model called GR3 and a robot called ByteMini. It's already working outside the lab and doesn't need special programming. You just tell it what to do. Here's how it works and why it's a big deal. So here's the setup. GR3 is ByteDance's large-scale vision language action model, and you can think of it as the robot's brain. It understands natural language, sees what's happening in its environment, and makes decisions on how to move and what to do. ByteMini is the physical body. It's the hardware that does the actual work. What makes this combination so interesting is how ByteDance built it. GR3 wasn't trained just on static data or pre-recorded commands. It learned through a multi-stage pipeline involving 3 key types of training data: robot trajectories, human demonstrations in virtual reality, and massive amounts of vision language data from the web. Let's break that down, because the way GR3 learns is the core of its power. First, ByteDance's researchers collected tens of thousands of real robot trajectories using teleoperation. They literally had humans control robots to demonstrate tasks. Things like putting clothes on hangers, sorting utensils, placing plates on racks, and more. But they didn't stop there. They also brought in virtual reality headsets and hand tracking tools to let human operators record their own natural motions. These human trajectories are faster to collect and capture real-world body language that's hard to replicate with robots, and then they topped it off with a curated dataset of web-scale vision language content. Captions, grounded images, interleaved language vision tasks, the whole range. GR3 was trained to connect what it sees and hears with what it does. The result is a model that generalizes shockingly well. GR3 can follow instructions it's never seen before, it can manipulate objects it wasn't trained on, and when integrated into the ByteMini robot, it doesn't just move like a machine, it actually makes decisions that feel contextual and deliberate. One video demo showed ByteMini being told to put the larger plate on the left shelf, and it scanned the options, identified which plate was bigger, and placed it exactly where it should. In another, it folded a shirt, inserted a hanger, and placed it on a clothing rack. No extra prompts, no hand-coded logic trees, just a single spoken instruction. And keep in mind, this robot isn't in a lab simulation. ByteDance has run extensive real-world trials with this system. In one task, the robot had to perform a complete long-horizon table bussing routine. Pack leftover food into a container, place cutlery in the bussing box, and throw trash in the bin. The robot had to navigate the space, switch between subtasks, and complete it all in one go. Using a flat instruction like clean up the dining table, GR3 achieved an average task progress of nearly 100%, even when the environment changed. New layouts, new objects, unfamiliar item groupings, it still followed through. Now, a big reason why GR3 handles this level of complexity is the architecture behind it. It's built with what ByteDance calls a mixture of transformers setup. It processes visual inputs from multiple camera angles, head, wrists, environment, and combines those with the parsed language commands. Then it runs that through what they call an action diffusion transformer, or DIT. That module predicts action sequences chunked into short segments, accounting for both position and timing. It's like the robot's version of short-term motor memory. The model also includes adaptive layer normalization and additional regularization layers, which stabilize training and boost instruction following precision. Technically, GR3 has around 4 billion parameters. That's no small model. But the impressive thing isn't the size, it's the efficiency. ByteDance designed the inference flow to be lightweight enough for real-time robotics. The action transformer uses only the key value cache from the final layers of the vision language model, cutting down processing time. It's a clever architectural decision that gives the system both depth and speed. And ByteMini, the physical robot, is just as sophisticated. It's a 22 degree of freedom bimanual platform. The arms each have 7 degrees of freedom and a special spherical wrist joint that enables precise rotation in tight spaces. These aren't clunky industrial arms, they're built for flexible manipulation. The platform is mobile, using an omnidirectional base that can lift or adjust its height to reach different surfaces. It has cameras on its head and both wrists, giving it close-up and wide-angle views for fine-tuned manipulation. What's more, the actuators in ByteMini's arms use quasi-direct drive principles, giving them high transparency and stability. That matters when you're folding fabric or handling delicate items. The robot is also equipped with a wireless emergency stop, a 10-hour battery pack, and a user interface built into a mounted screen. It's clearly designed to function autonomously in dynamic environments. One of the standout experiments involved cloth manipulation, an infamously difficult problem in robotics. GR3 was tasked with hanging a shirt on a hanger and placing it on a rack. But here's the kicker. The model was only trained on long-sleeve shirts. In testing, they gave it short-sleeved clothes, and it still figured it out. It adjusted its grasping position, maneuvered the fabric, and completed the task with over 75% success rate. That kind of zero-shot generalization is nearly unheard of in this domain. Another major test was few-shot learning with human trajectory data. ByteDance collected human motions using virtual reality headsets, specifically the Pico 4 Ultra Enterprise. With just 10 demonstration examples per object, GR3 was able to boost its success rate from 58% to 86% on previously unseen tasks. It didn't forget the things it already knew either. The performance on known tasks stayed high. That's a huge deal for adaptive training. It means you can teach the robot a new task in under an hour using only cheap, accessible, virtual reality gear. But it doesn't end there. ByteDance's SEED team, the research division behind BR3, has scaled up robot deployment as well. They've reportedly produced over 1,000 robots in the past 2.5 years. Most of those are simpler wheeled logistics bots, autonomous mobile robots used to move parcels and components in warehouses. These don't have arms, but they're already operating in ByteDance's own e-commerce facilities and in partner companies like SF Express and BYD Electronics. So they're not just building tech for show, they're building tech for logistics, productivity, and potentially the home. Internally, ByteDance's robotics team has grown to around 150 researchers with a clear long-term goal: embodied intelligence. That's the holy grail of robotics, AI systems that don't just compute but also act, reason, and interact with the physical world. This isn't just a side project to flex for investors. ByteDance created the seed department back in 2023, just after OpenAI's breakout with ChatGPT, and it's been scaling ever since. They've filed patents, posted job openings, and even developed their own simulation environments for training. ByteDance's AI team says GR3 outperforms other state-of-the-art models, including Pi 0.5, across a range of tasks. In generalizable pick-and-place scenarios, GR3 boosted success rates by over 30% when objects, environments, or instructions were completely new. In long horizon scenarios like table busing, it nailed instruction following at 97.5%, while the competition hovered around 50%. And in tests involving invalid tasks, like telling the robot to move an object that wasn't there, GR3 didn't break. It simply stood still and refrained from action, which is exactly what you want. Now, not everything is perfect. ByteDance's own technical report mentions that GR3 still struggles with certain unseen object shapes and novel combinations. The left collar handling during shirt folding, for instance, was a consistent failure point. That's where they plan to improve: more training, more diverse data, and eventually reinforcement learning to move beyond pure imitation. But even with those limitations, the performance is ahead of anything we've seen from other major players this year. The tech stack they've built, from training pipelines to physical platforms, is robust and well integrated. The fact that they can train a robot brain using only 10 human demos per object and deploy it in real environments with consistent performance, that's not a demo trick, that's infrastructure. There's also the geopolitical angle. ByteDance is still under scrutiny from United States regulators. At the same time they're deploying GR3, they're also fending off pressure to sell off their TikTok operations in the States. United States Commerce Secretary Howard Lutnick has been clear: Americans must control the tech and the algorithm, or TikTok could be banned entirely.
If that deal gets approved then by the Chinese, then that deal will happen. If they don't approve it, then TikTok is going to go dark.
So, while ByteDance is showing off cutting-edge robotics, it's also maneuvering under intense political pressure. That could shape how this tech gets licensed, distributed, or even regulated in the coming years. Meanwhile, co-founder Zhang Yiming, who stepped down as chief executive officer in 2021, is still heavily involved. He travels between Singapore and Beijing to oversee major research and development decisions. His vision for ByteDance includes a strong pivot toward embodied AI, and clearly, GR3 and ByteMini are part of that plan. This isn't just about folding shirts. ByteDance is making a robot that understands commands, learns fast, and does real tasks on its own. ByteMini isn't on the market yet, but the tech is ready. It works, it trains fast, and it scales. If nothing blocks them, ByteDance could play a big role in the future of robotics. That's all for today. If you found this interesting, subscribe and stick around. More on AI and robotics coming soon.